Okay, so on my unit 12, I'm going to create a new file. Let's call it stats.py. Just any file you want to call it. Okay, so two libraries you want to look at. Well, actually, we can try three, so much time we have. One of these is the matplotlib. Okay, this is for plotting graphs, mainly for that, like pie charts, graph, scatter charts, bar charts. You can use that to do all those stuff. The other one is the Numpy, usually for numeric only, and it's using what's called the ND array. So this is a ND means the N stands for multi-dimensional, the N dimension. So this is very useful for that. The dimensional arrays. And usually it's used only for data. That's why it's num. Right? Num is numeric Python. And the last one I want to look at is the statistics. This is for statistical data stuff. So those are three libraries. A very powerful one, which probably won't have time to explore, is called the Panda. This is a very powerful library used for like research and a lot of statistical manipulation and so on. So that is a very powerful library. But let's explore the first two first, and I want to explore the Numpy first. Okay, Numpy is a library or package you can install into your system. To check if you have it installed already, which I think you might have already, you can go over to the Explorer, the console over here, and just type and like try as if you want to import it. And you can do that in the console here, right? It's interactive, so you can say import numpy, hit enter, and as you can see, I don't have any errors, so that means it's already included in Anaconda. Okay, if it's not there, it will throw an error. It's not found, right? You can also check for the matplotlib. I think that's also included, so you can say import matplotlib for library, and I do have that as well. So I want to try the other one too, right? Import stat should be in there. It's a very common one. So that's there. And import panda. So as you can see, panda is not there. So usually it's a extra module you can import. But the ones that we need are all there. So numpy, matplot, and statistics. So to use it, we just import it in our code. So we go here to the left side of the code, import the numpy. And that includes everything from that numpy module. If you want to know what's inside this module, you can find it in the C drive somewhere there. Or the easiest way is just basically you click on it, highlight it, and just right click and choose, I think this would be something like go to definition. Yeah, go to definition. And that will actually find that file. It's a Python file. Open it right here in your file. It loads that, underscore init underscore .py. That is a special file that is usually located inside a folder, and it will make that folder a package. So a package must have the init .py file. Kind of similar to, if you remember, a class also has a similar name, right? Except it's a function and not a file. So a function will make that class a class. A file will make that folder a package. If you're coming from a Node.js background, this would be similar to what's called the package.json file, right? Okay. And then, so here I have a lot of code information, a lot of import statements. It depends on other modules as well. But if you explore this, here you see a lot of these other data, other packages. The dot, it just means in the current directory, wherever this init.py is installed. So it's inside that folder, right? So from the current folder, import this library and that library. That's what it's saying here. And so it depends on a lot of modules, the polynomial, the random, and maybe other libraries as well. Okay, so you don't see here because it will load those packages and you use it in here. Okay, so back here, then you can do some things with Numpy. And again, it's a library, so when you use it, Numpy has some functions. And to quickly find those functions, you can go to the console again over here. And if you type, let's see if this works, dir for directory, numpy. And that will list all the libraries, all the functions and variables you can use for inside that package. You can see there's a lot of them. Okay, if you scroll up all the way to where I call that, and we learned last time again, it's a lot. Actually, there are many more. The list is too long, so it chops off from wherever, from A all the way down to the B here. It's a lot, right? So it's a big, big library. But some of the things that we'll be using are to create arrays. Okay, so Numpy, to use it, you just use like I guess the two most common ones functions that you use is to generate numbers. So usually when we create numbers, we use list for arrays. And Python itself, Python has another library called array. We never actually used it before, but it's an array function called library that allows you to create arrays. And usually, again, that array library is useful only for numbers. I haven't done it yet, but for example, if I go here, import the array library from Python. So the array allows you to create arrays. And so array, again, if you go over here to the console, if you type import the array first, then if I do dir array, it lists me some stuff in here, right? Not a lot of stuff in there, right? Kind of small. You see there's one thing in there called array, and I think that's a function. And you can use that because the rest of the top are just constant, right? I mean private. So use the array to generate array. And since the library is called array, then when I call it, we'll say array.array. Right? So if we go here, put like a data equals array.array. So you have a function like that, right? It's kind of confusing, so you can rename this library with an alias, right? So array maybe as just maybe AR for array, or just A. It doesn't matter, right? So that way it's shortened the code. A.array. And again, this array function takes two parameters. So here, the first one is the type code. Again, this is not NumPy yet. Okay, I'm gonna compare the array built into Python versus the NumPy. It's a separate library. So type code is the type of Unicode you can use to store data. So it's kind of interesting because with the array, all the data type must be of the same type. You can't mix and match them. It's almost like a strictly typed language. So type code is really, it's a one or two character about the type of data, and usually again deal with numbers. So if it's an integer, I've just put like a character I here to denote that all my numbers are going to be just integer. And then after that, you have the initializer. Initializer is really just a list of numbers. So the second parameter is just numbers. So 1, 2, 4, 6, 7, 10, and so on. So that's how I create an array and using the array module or library. And after that, you can just access it just like you would normally using the array, the index. Right? So save that, and let's clear my console over here. I run it, so it stays in memory. So data now exists in memory. And if I do my variable, you see that there's nothing there, it's an object. If I type in data, right, you see that it has the same, it's kind of similar here. It's an array. If you don't know what the type is, you just, again, type, and you pass in data, and it tells you that's an array.array. And to get those numbers, 2, 4, 6, 7, 10, I just access like this using index. So data of 0 gives me the first element, and so forth, right? So data of 3 gives me 7, 10. Okay? And you can also, like, 3 equals to 10. You can change the data as well, just like a regular list or array before, right? Nothing different in modifying these data. Now, so you have some arrays built into this system here. The only thing you cannot do with the array is you cannot have multiple dimensions. It's only a single dimension. So if I want to go in here and modify this to a 2-dimension, say if I go and add another column, so make a 2 by 2 table, 3, 5, 9, 11. Okay, I can't do that because you will wrap those inside a bracket and a bracket, right? That's how you create 2 dimensions. Rows, first row and then second row, you have 4 columns each. Okay, if I save that, and let's see if I run it again, you see that I have an error, right? And it just doesn't accept that. You cannot create multi-dimensional array using the array library. So instead of doing that, we end up just using list, right? And list in Python gives you that flexibility, and you can build on multiple dimensions using list. And so what the Numpy does is basically extends the array module and combines that with the list, so you have pretty much like both worlds. It deals with mostly numbers, and you can build multiple dimensions in your array very easily, very quickly. Not only that, you can change the shape of your table, because right now it's a 2 by 4, right? And you can quickly change that to any size you want, as long as those numbers and those columns and rows, they're all matched up. Okay, so this is the array method. Now let's switch over to the Numpy function, Numpy method. So I'm going to go and just comment these out. So the Numpy. Again, if you want to use it, it'll be numpy dot something, so you can make this to a shortcut. I'm just going to use np for numpy. Okay, it's kind of common to use np or npy. Make it shorter. All right, so I'm going to go in here and create data again. Data is equal to numpy dot. As you can type dot, it gives you all those functions we saw earlier. The whole list from A all the way down to Z. And the one that we want is something called array, kind of similar to the array. And the inside here is basically you put your array. The object, the data type will be none, copy, true, and or. We're not going to care about those. We're just going to put the array here. So I could go and put in here just a single list. It has to be either a list are a tuple. Okay, so this is very common to use the list like this. So I put numbers here: 1, 1, 2, 3, 4, 5, 7, 8, 9, 10. So I have 10 numbers inside the list array of integers. And then I'm going to go over here and clear my console, and we'll do most of the examples in the console because it's faster. But you can write those in the code too. When you actually process data, you put in the code. So I run it, and here we go. My data is now, as you can see, it's a list of integers, 10 numbers. And the size, there's a size here. It tells you the size is 10. So it's a 10, right? It's a row or column. In this case, you think about it as a row. A row has 10 elements. So data has those information. As you can see, it's an array. If you type what type of data it is, it's going to say it's a numpy.nd array. Okay, so the nd against the multiple dimensional array in NumPy. The neat thing about this is once you have the data in here, you can change its shape, meaning you can change the structure of the array on the fly very quickly. So if you want to know the size, there's a function called size, right? So just say data.size gives me the size of 10. It just tells me there are 10 elements. If you want to know the dimension of this array, you could do, there's a function called ndim. So it's a data.n dimension. It gives me, it's a one-dimensional array. It is just one-dimensional. You see it there, right? So these are some very useful functions you can use, or properties you can use. If you want to know the size of or the shape, then there's a shape property as well. So data.shape, it tells you it's a 10, comma, empty. It just means it's one row or column because it's a one-dimensional array. And the cool thing is that you can manipulate the shape here. Instead of one dimension, I can change it to 2 dimensions right here. So let me go ahead and do that. I'm going to say data dot, I'm going to change the shape, so do a reshape. Inside the reshape function, as you can see, you have some information there, 2 parameters. So we'll just do it with the first one. And the shape takes rows and columns, basically. So I want this to be because I know I have 10 digits. Okay, and the columns have to work, because usually the columns, you multiply them, right? So this is, 10 by 1, so you get 10 numbers. If you want to change the shape to, let's just say 10 numbers, so it's a 2 by 5, or 5 by 2. That's the only way I can do it. I can't do it any other way. If you multiply them, you get the 2 by 5 or 5 by 2. So you can reshape it to 2 by 5. You see that now it's changed to a 2-dimensional array with all the numbers split automatically for you. And that is, happens automatically. You can't control it. And it reshaped that for you. It does not change the original data. As you can see, the data still is the 10, a single dimension, right? So it returns a new array. If you want to save it to another list of data, that you would assign that to a new variable. For example, if I put d1 equals that, then now d1, as you can see, is now a 2-dimensional array containing the original data, but now it's split into 2 dimensions. Okay. But my data is still the 1-dimensional array. So I can change it to any shape I want as long as the numbers match. So if I go in data.reshape, 5 by 2, I get a 5 rows, 2 columns. Again, the quantities have to match up. So 5 times 2 gets 10, and it will put that for you automatically for you. If you do anything else besides that, they don't add up, then it doesn't work. So if I do like data dot reshape, 4 by 4, then it doesn't work because the size don't match. I'm losing some data, so it doesn't allow that. Okay, so that's pretty cool. Now let's do something. I'm going to go back to my original data here. I can change it in here, but let's go back to original data. And instead of saying 10, I'm going to choose 9. Is it 9? Let's see. Well, let's see. 9 would be like a 3 by 3. That's it, right? And let's change that one. Let's see. 9 is not that cool. What about 12? 11, not so interesting. 12. So the 12 elements. Create my console here, clear the console, run it again. Okay, so I have 12 elements in my data now. And so here is data of 12. I want to reshape this again. I can do like before, data.reshape, 2 by 6. I can do that very easily. 4 by 3, right? You see how quickly this can be created with 3 by 4. As long as we add up to 12. What else can you add up to 12? 2 by 2 by 3, right? Yeah, so you can do that. So you can say, I want to be a 2 by 2 by 3. So we just did a 3-dimensional array, right? 2 rows, 2 columns, and 3 layers deep. The X and Y and Z axis. Or you can go any order, right? 3 by 2 by 2, or 2 by 3 by 2. It doesn't matter. As long as these numbers matched up, you can see how easily you can generate these data to do like a statistical data processing. And imagine you have to do this in your code manually or write a code to do this. You have to go loop through every element of the array, break it up, create new array, new column, new row, based on the number of rows and columns. So it does automatically for you behind the scene. So I'm pretty sure the code behind it is the same as we just talked about. You have to really go and loop through that and then recreate the whole array again. That's why it did not change the original data, right? It's just recreate a new list of a new array, and then if you want to keep that, you can assign it to data or assign it to a different variable. So very, very easily, very powerful in this example here. So that's using the array. The next one I want to look at is something kind of similar to the range. So let's turn this off and go down here. So using the array, you can generate unique numbers. Here I'm just using 1, 2, 3, 12, which is kind of in a lazy way to do it, but I can have different numbers and here. If you don't care about, the uniqueness, these numbers, if you just want numbers in a particular certain order, then you can use the range. Kind of similar to what we did with the range when we do the sorting stuff. So I can do something like data equals np dot a range, just a in the range. And here, if you look at it, it says the start, stop, and the step. Very similar to the range when we did the loop. You start with any number you want, stop at any number you want, and choose any step. So if we just pick, let's just say, just go again with 12. That means it's going to print the numbers or create an array, a one-dimensional array from 0 through 11. I think 12 is not inclusive. Same thing with the range before, right? You do a loop from 0 to 10. It doesn't include that 12. If you want to include that 12, then you have to put 13. So save that and go and then clear my console. Let's run it to see my data. And here's my data. It has the numbers auto-generated, added, created from 0 through 11 because again it does not include 12. And it always starts from 0 to whatever the number is minus 1, right? The same rule with the range before. We did it before. Okay, so you saw how that works. So now we can just do here in the console. I'm going to redo my data. So data equals, and we'll use the NP. I'm not sure if it's NP is in here. Is NP in here? Yeah, it is. Okay. So I'm going to go data equals NP dot a range. And I want to start from not 0, but from 1 to 12 inclusive. So I want to put 13, right? So by doing that, now I have a new range from 1 through 12, including 12. And then after that, you can do the reshape thing, right? You can manipulate it however you want to reshape it. So just like before, data.reshape. It's a 12, so 3 by 4, and I got my array in 3 rows with 4 columns. And then now it's a two-dimensional, so you can do data. So that means if I go back and set to a new data, call it D equals that new data, because that doesn't change the original array. So D is that new data, 3 by 4, and if you want to know the shape, D.shape tells you is it 3 by 4. If you want to know the dimension, it should be a two-dimensional array. D.indem is a two-dimensional array. Okay. And if you go D equals D.reshape, reshape D, oh, it's a 12, so you can do like earlier 2 by 3 by 2. So it's a three-dimensional now, and you can do the D-indem. It tells you that it's a three-dimensional array. This is very easy to manipulate data, to change data, and then from here you can do your test, right? Predictions, or build your graphs very quickly based on these numbers. Okay, so back to the data. I did that earlier. My data was this one, right? From 1 to 13. And just like the range, I could choose like from 1 through not 13, but maybe, let's just say through 50, and I want every fifth number only. So you can do that. So the step will be 5. So in this case, 1 and plus 5 is 6, plus 5 is 11, all the way to 50 or 49 if it's included in that. But if I do that, then my data now looks like that. It's all the numbers starting from 1 all the way to 49 inclusive. But I'm going to step through those numbers by 5 instead. Okay, so like the range. And so let's say I have another one. I call it the data 2 equals from 1 to 50 also. The same, well, let's see, maybe it's, no, I'm going to choose a different number. Let's just say I want to choose from 10 through That's what 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 10 numbers. I want to go from 10 to 50, 10 numbers, so let's go 500. 10 to 500 by, no, that's too much, right? 10, 20, 30, 40, 50. Well, I'm trying to put, I'm trying to get the same number of size. It's 14, so yeah, that's too many. Let's just try, 5, 8. Let's try 4, 10, okay. So I used the step 4. So it's a 10 by, it's a 10. Data also has 10. Oops. So data has 10. Data 2 also has 10 numbers, right? So you can easily generate numbers like that. And just like the rule we did with the list and so forth, you can add new data, subtract them one by one or into the array itself. So that means I can do something like new data 3 equals, you can do something like data 2 minus data 1, right? I think, oh, not data 1, just data. Right now. So data 2 minus data, and then you get a new data 3 that has the difference from those two data arrays. So you can see how data can be easily subtracted or deleted from, modified from this array. I wish other languages do this, but they don't have this option. And if you try to add, what do you think you're going to get? Right? You add those, each single digit, each element to that existing element, and you add those values. And if you remember, you did list. Remember we did list. List is go A, like 1, 2, 3, and then B is 5, 6, 7. Okay, if you add the list, C equals A plus B, right? You don't get that. The list is different. It doesn't add a value. It combines the elements of B and then combines that with A, and then you get a new list. But with the array, if you do addition, you're actually adding the actual element inside the two arrays, and you add them up into the correct slots here. Or you subtract them, or you do something else, right? So if I do go back to data 3, and instead of plus, I can do multiplication, division, right? It's very nice. That's so cool about Numpy. We're just touching about arrays. There's actually many more that you can do with that. And notice again when I did the array here, go back to my screen. When I create my list from 1, arrange from 1 to 12, and if you want to shape it, you could do like, and then data is equals np dot, data dot reshape, and then you say 3 by 4, right? You can do that, right? We did that. Okay, you create the list, it's 12 numbers, and then you reshape it to a 3 by 4 array instead. So here you have 2-dimensional, or actually, yeah, 2-dimensional and a 3 by 4. And Python allows you to also chain these functions too. Okay, so you don't have to do like 2 lines here. I could just chain this together, meaning I could just remove this data equal data dot here and chain the function to this one. So you can do that. So I create my list first, and then I reshape it. So I could do a 3 by 2 by 2. So you can change some functions in Python as well. It's called method chaining, very common in most object-oriented languages, especially JavaScript and jQuery. Okay, so there's a lot more information. If you want to learn more about it, just go to numpy.com, I think, or .org maybe. I think they have maybe a very extensive documentation to do more than just what we just did here. But still, this is how you generate data. Once you get the data, what do you do with those data, right? There's a lot of functions built into it. Okay, so the next one we want to look at is using the NumPy. You could use that to generate data very quickly, and then you will use the matplotlib to plot data. Okay, so let's take a look at the plot. I'm going to turn this data off, and I'm going to import up here the matplotlib. But the lib here has a lot of other libraries. So, for example, if I go over here and import, actually, I just do here. Again, right click on it and then select and go to definition. Right. So it tells you what it looks like, and it's a big file. And then it's a lot of other imports. Okay. And if you go here, one of the ones that we want to use is called, I believe it's called a pyplot. And let's see if we can find it here. Yeah, it's a pyplot that we can use to plot. Okay, so back here then, I don't want to get the whole matplot here. I still want to get the one that says pyplot. So matplotlib.pyplot. That's the one I'm going to use to plot data. And if you want to use it, you have to type the whole thing, right? That's a lot of typing to do. So you can use an alias again. A very common one is to put a PLT for plot. Or you just put, yeah, just PLT, because the word plot is a keyword, so you don't want to use that. Just put PLT or MPLT, whatever you use it. Okay, so this plot here, if you type in PLT dot, you see that it also has a drop down of some other functions you can use. Okay, and you have the arrows, you can draw all the stuff, the axis, you draw the box, you can draw the box plot, label, see label here, you connect, and the one I want to use here is basically to plot some data. Okay, you can draw figures and things like that. So plot is one of those functions you can use and has several parameters here. Okay, so remember the star args and the star keyword arguments. Those are like it's like an endless list of arguments you can pass to it. The first three are those three: the scale x, scale y, and then the data. So what you have in here is you can actually put a list. This is for the scale x, and this is for the y. So the x-axis and y-axis is a 2D plot. And you can put numbers in here, and the number has to match. I mean, the size has to match. If it's a 2 by 2 or 2 by 4 or 10 by 10, right? So the story has to match these numbers. So let's just say what the x-axis is. It doesn't mean that it's not the actual numbers on the x-axis. It's just to the actual. It's a particular I guess dot or a number on the x-axis, and it will automatically generate the size of the x-axis and the y-axis for you. Right. So if you're thinking about like you want to plot something on the graph, the x-axis could be time, right? So you can start from when I reach at time 1, I get a certain number on the x and the y-axis. Maybe I reach a number 10. When I reach time 3, it could be seconds or milliseconds. Maybe I would get a 25. So if I do a time of 5, every odd number of times, I come back down to, let's just say, 15, right? And I'll just do one more. And at the 7th time mark, I come back down to, let's just say, 3. Okay, so these are actual numbers on the x-axis, but it will automatically plot that x-axis for you based on the largest number you have. So from 1 to 7, so the 7 is the largest, so you might put 7 or you might go from 1 to 10. Same for the x-axis. The largest number is 25. That's the highest. Lowest is 3. So again, from 0 up to the largest number. It will plot that for you. So if I say that, and usually when you plot it, you want to show it, plt.show. So you show it's a function, you call it, you show the graph. And if you run it now, and you see the graph over here on the left, on the right side, the output, right? So again, it's automatically generated for you from 1 to 7. It's evenly divided, which is good. And you can zoom in, zoom out. So you can write some zoom in, zoom out to zoom in. If you go deeper, then those numbers get regenerated to be more specific. So just plotted a graph, and here it's a plot. So the plot means a line plot, right? From the first one, I get a 10. So here's a 10. At 3, I get a 15. Somewhere here. I mean 25, right? Up here. And then at time 5, I get a 15. And then time 7, I get a 3. Okay. You can plot multiple graphs on the same graph. So the next one I could use like at the same time, maybe a different numbers. So this could be at 7, maybe 15, and maybe like 10, and then 13. Again, if I run, you see that now I have 2 lines on the chart. And it's automatically colored for you, so you can see it. If you don't like the color, you can change it too, I think. Yeah, you can change the color. Just specify the color equals to like I think it's R, the short for red. We just have the whole word red here. Let's see. The first one is going to be red instead of the default blue, right? And then the next one will take the default blue, and then green, orange, green, whatever. So you can control the colors if you want. And you want to know what the x and y axes are. Also, there's no labels. You can actually add the label too. And to do that, then you would use the plt dot. You can see like x label. You see that here. You give a label. Label could be like time. It's time in maybe seconds, right? And then PLTY label would be something like, I don't know, height, I guess, in maybe feet or something, or whatever this is. And if you want to measure what this is, you can also give it a title. Title is I don't know, let's just say jump something. And now when I run it, you get those labels to now explain what that graph is about. So time and speed, and so on. And the next thing you can do is, okay, what does the red line represent? What does the blue line represent? Right? So then you can define those as well. So when you create this label, the plot up here, I put the color red. I chose red. I just choose a second of default. I can give it a label here. So the label will be equals to what this is about. This is for maybe like a CPU1. I don't know. Let's call it CPU1. The second is for CPU2 or something, right? So give it a label. But when I run it, it doesn't show there. I don't think it shows. Yeah, it doesn't list there. And to see the label, then you have to add another function called legend. Show the legend. And that should show the legend in your plot. So now you have more information about what this graph is, right? The CPU is red, second is blue, and then jump and feet, whatever it is. I don't know how they jump, but it could be player 1, player 2 maybe. And you can add more graph to this. And so it's pretty neat. If you want to use a not plot, you can also use the scatter. The scatter, I show you one scatter, one plot. The scatter, you use the dot scatter over time. And then, so in that way, it's kind of hard to see what they are, but it is scattered throughout time. And if you want to connect those dots, not using a solid line here, then I think you can use something like the letter R followed by like a dash dash for a dash. So if, yeah, I forgot how to use this one. I always see R0. RO. Oh, maybe you need to go first. Yeah, maybe over here. Yeah, I forgot how to do it. So it always gets me. But you can change so that it's instead of just dots like this, it has a dotted line, or you can change the shape instead of the circle red here, change it to a triangle or an arrow or different shape as well. And so you can also, instead of plot, scatter, maybe you want to use bar. Use the bar chart. And just by doing that, it converts to bar chart instead. Right? And you see that it's also very common to see some graph that looks like this, is both bar and plot. Right? You can plot together, maybe a different color, maybe a gray or something. So you can mix and match all these different graphs in the same graph, different charts. Okay, I think it's time for a break. So let's take a break and we'll come back and we'll do a little bit more with statistics and how to read data from a file and plot them on the graph.